Hannah Powe, so I'm the genomic specialist for southern beef as well as dairy at Neogen Australasia. So the topic I'll be covering here today will be the genetics of tenderness and the commercial application of genomic technologies. I do just want to preface I'm not a geneticist myself, so there is going to be some questions that I'm not going to probably be able to answer, but if there is anything at that higher level, I just refer back to our R&D manager and then we'll get you some answers as soon as possible. So our key got to remember to do this one as well. Our key focus areas will be the Neogen overview. We'll go through SPI, where you currently are sitting with a bit of your testing stats, updates to your tenderness testing, understanding genomics and where it fits. So what is genomics, what isn't genomics, the importance of a reference population, and then where to next. So Neogen, so some of you might know or might not know about Neogen, but we are the longest and largest, the largest and longest standing genomic lab here in Australia. So prior to it being Neogen, we were at the University of UQ. In 2017, Neogen, which is a global company, acquired the facility up there, and then in I think it was 2022, we built the state-of-the-art lab that's up at Bundamba at Ipswich. It's the largest lab that's based in the Southern Hemisphere. It's a pretty exceptional facility, so if you're ever up in Bundamba near Ipswich there, make sure you go through the lab. I also just wanted to touch that some of you probably might have heard that we are going through a bit of divestiture at the moment. So Neogen has 3 arms globally, so food safety, animal safety, and then genomics. So they're just selling off the global genomics arm, which is currently in the last few stages of negotiations and contract signing. So in the new year, we should have some answers around that. But we just want to give you guys confidence that it is business as usual. The whole lab, all of us, gets transacted in that transition. So everything that we're working with Speckle Park will continue on into the future. So in terms of your testing and your current bundle, I just wanted to touch on a few things. So we've had a few updates to your TSU ordering. Now it's pretty streamlined. You order on that JOP form, it comes through to us, and then we send it out. On top of that, I just included your pipeline there so you guys kind of understand, and I can talk a little bit more about what we kind of offer for you. So basically, once you get those TSUs, you're completing your DNA submission form, you're sending it to SPI for processing, the batch paperwork's given back to you, you're sending it on to us. Once we receive it, we are completing the genotyping, and then we upload that into the SPI share file. So that's something we just want to emphasize and just basically bust any myths there, because some people, and this is across all breeds and across all species, we always get asked, oh, but why aren't you you give us our genomically enhanced EBVs, but we only do the service providing for the genotyping services, and then that goes into breed plan, or it goes into the genetic evaluation. So we're simply the service providers, analysing that data, genotyping, and then allowing it to go into a breed plan. And so we could finish, that's another question we always get asked, is our samples done in the lab? Yes, they can be, but then they also need to go through a run and get that single-step analysis for the genomically enhanced EBVs. We do report out your qualitative traits, so when you're looking at that, your horn pole, your coat colour for you guys, and your genetic conditions, myostatin, we are reporting that out as well. I think it's also important to note, I know I get asked a lot, can I get a copy of my genotype? But the genotype is just a lot of combinations and a lot of A's and B's in a spreadsheet. So for you guys, there's no way to interpret that until it goes through a genetic evaluation. The other thing I just wanted to touch on, which Lockie has mentioned and announced to you guys, and you're probably a bit excited about now, is that we've had some changes to your SPI bundle inclusion. So previously you had the 100K that gave you that DNA profile that allows you to get genomically enhanced EBVs. It also allowed you to have that parentage component, coat, myostatin, leptin, and horn pole. But now we will be reporting tenderness as a free inclusion, which is pretty exciting for you guys. I will touch on that in a little bit more in a little bit. As Lockie mentioned previously, if you did the tenderness add-on, you were simply getting the 0 to 10 score. Now we're going to be offering the markers as well as that at no additional cost. So I think you probably have already seen a lot of this and it might be a little bit of an overview, but if you guys have any questions while we're on this tenderness stuff now, feel free to put your hand up and I'll try and answer them as we're going. But I think Lockie also spoke about this, how there's different combinations and those combinations can make up different tenderness scores. So it's not simply just getting a 7, it's now taking it that step further and understanding what actual markers they are carrying and what's contributing to that score. Also, I just wanted to highlight that there has been expressions of interest that has gone out to all members in regards to adding it or getting a tenderness score and marker report on tested samples. So we are able to do that. I think it was December 12th that you guys need to just put through a list of your animals through to Speckle Park and to Maddie, and she will collate all that and then send it on to us. For us, it's just easier to do that bulk run and just get it all reported. So I encourage you all to do that because that'll probably be a once-off offer to do that. I also just wanted to touch on that you'll only get the marker report if you select it in the bundle. If you get it as a standalone test or you get it as an add-on, you'll just get the 1 to 10 score. So it's important to note to order it within the bundle because that's how we've got access to this and how you guys will get access to that whole marker report. So just make sure that you add it to you're always selecting the Speckle Park bundle if that's what you're interested in getting. I think we can go skim over this, but did anyone have any questions on this? Lockie spoke in depth about how our test looks at the 2 calpain and then the 1 calpastatin genes, and then we'll be reporting that. And then that was also the other table that Lockie went pretty well over, and you can see how it shows you the Warner-Bratz, the shear force scores, and you want them more negative. He also spoke about that, how these were calculated based on the validation study and the breeds included in that. I also just want to make sure I emphasise, as Lockie did, that Speckle Park were not in the reference population in that validation test. Therefore, you just have to be wary with the results you're getting. As he also mentioned, you are linked though to some of the breeds that are included in that. So therefore, you should have some linkage there. He also mentioned this, but it's always great to ensure that you guys have a thorough understanding that we are looking at the genotype, but then there's a whole environmental factor that contributes to that too. So when we're looking at an animal, it's 30 to 40% of what you see is going to be your genomic component, so that genotype, and then everything else on top of that's that environmental. He used a great example in those previous slides of showing animals with the same tenderness score of 10 and how that whole docility component came into it as well. And then you're going to be looking at all your other factors such as HGP use as well as your post-slaughter interventions there. So it's just important to make sure that you guys have that understanding of that environmental, that age factor, your breed composition, everything else that comes into play, and on top of that genomic, that genotype influence there.
Excuse me, Hannah.
Yeah?
Just a great presentation, and it's a really good test that's being included. Does that also, can that be included when you're doing mating predictions in the EBVs?
Not at this stage. Not at this stage. That would have to be something that you look to develop into the future once you have some more data behind it. But at this stage, yeah, you'd just more so be looking yourself at what your scores are. And as Lockie was saying, you could improve it within generations, but it's not going to be built into any mating predictors at this stage. Good question. So I just thought I'd touch on a few stats and don't get too in depth with these specific line items here because obviously you can't look at the grand total of 5,760 there because that's including the multiple tests that we do within that. But I just wanted to touch on, this is a lot of what I do when I work with the Breed Society. I'm also analysing where your stats are. We kind of aiming moving forward to give you quarterly reports to your board of where you're sitting at now that we've gone through and be able to collate this. Notably, there is different tables there, and that's because of a system update. We transitioned to SAP from 24 to FY24 to FY25. But I guess the main take home here is that your bundle testing has increased. So we work June 1st to May, so we finished FY25 in 31st of May this year. So you were up 760 samples on that bundle, and that's approximately 20% growth across the breed. So I think that's showing that you guys are really see that there is value in that genomic testing, and are using it as well as from that breed requirement perspective. On top of that, this is the Q1 results. So we're just about to finish Q2, and I'll hopefully be able to get you some more data from that once we finish the month out and do some good calculations there. But when you're looking at that, I guess you're seeing that growth again because you've done 1,585 bundle samples, so therefore you're at approximately that 34% of last year, and you're trajectorying to have that year-on-year growth. So if we just have a bit of a dive into genomics and I guess the importance of genetics, I just thought we'd do a bit of an overview of that. What is genomics, what isn't genomics, and then get into that reference population and let you guys ask any questions if you just have some uncertainties there. But I guess the importance of genetics is that genetic improvement is achieved when the average genetic value of the offspring is higher than the average value of the previous generation. So it's really important to note that it is permanent, it's cumulative, so you're going to be able to get small gains that accumulate into across multiple generations. So once you start selecting for some traits, you can really build on them. I'm not sure if you guys are familiar with the breeder's equation, but that's where we kind of fit in this. So genetic gain is a combination of selection accuracy, genetic variation, selection intensity, and then over that genetic interval. So we really play the role in that selection accuracy. So we're allowing you to more accurately understand how an animal is going to perform, specifically for hard to measure traits, and that's through calculating that breeding value. So I just wanted to also highlight that progeny equivalence. So you've probably all heard that you're allowing to make decisions on animals earlier in life, but it's also on those hard to measure traits. So for instance, the progeny equivalence refers to the number of progeny needed to achieve the same increase in accuracy as genomic evaluation. So I've just touched on a few there, and this is always going to be breed dependent to evaluation dependent. So if you look it up online, you're going to see a lot of different tables, but I've just highlighted a few ones that are probably important there. So that's 22 birth records you'd have to submit on one sire to get the same increase in accuracy as you would to do a genomic test. Same with 25 weight records, 12 plus carcass records, and around 11 IMF records. A lot of that has to do with your heritability of traits too, and we'll talk on that a little bit. Selection intensity is just pretty self-explanatory there. So through genomics, you'll be able to identify inferior, superior animals, and particularly reproduce out of those superior animals more often, and therefore drive genetic gain quicker. So what is genomics? It's utilising information from an animal's DNA to predict or improve the prediction of breeding values. It improves your selection of breeding animals within your enterprise and then within your breed, and it extends out to the supply chain. So you can really start driving some efficiencies and productivity and profitability within your herd, but then that flows into breed and throughout the supply chain. So there's 4 key steps involved that we've outlined there. So it's the collection of DNA samples. We do the genotyping. That's the prediction of the breeding values, and then you can make some robust decisions after that. So what genomics is not. So I guess you guys have probably heard, can't I just take a genotype and then know exactly what trait it's going to carry for IMF, or exactly what trait it's going to carry for growth, for instance. So it does not replace the need for breeding values, so it still needs to go through that, because as Lockie commented, there is a lot of traits that are polygenic. So when you're thinking about polygenic traits, multiple genes are actually influencing it, so a lot of your growth factors influence that. On that, we don't know the genes that actually have influence, and they largely have not been identified as of yet. And so it's based on gene markers and that relationship we see between animals. It doesn't replace the need to collect performance measurements, and we'll talk about this a little bit more, but it's crucial for updating that genomic reference population and maximising the accuracy of breeding values. I'll talk on that a little bit more, but there's certain traits that it's going to need more data to be coming into the system, more genotypes to be coming into the system to lift your accuracies due to heritabilities. So this is just a brief overview of the value proposition of genomic selection. I think a lot of you will already know about a lot of this, so you can make accurate selection decisions. As I mentioned, it's going to be increasing your accuracy because we know more about the animals, which leads to faster genetic improvement. You can make selections earlier in life on a lot of those hard to measure traits also, which means you can utilise bulls. I guess you guys are probably very familiar with the Wagyu industry. They can now take a test on a calf at birth and know whether they'll keep him in the system or cut him out pretty quickly, which is just really drives that profitability standpoint. There's also allowing you to have selection for new traits that can't be routinely measured on farm. So there is some breeds that have access to immune competence traits, and then there is work being developed on that methane emissions. Similarly, that NFI and DFI, depending on what you're looking at. So you can't routinely collect that on farm, so you're going to get access through that from the work that's been done with Genomics. It also is now, as you probably are aware, is starting to really get some traction in that commercial space. So it's allowing them to make some really robust decision on a DNA-only standpoint to understand the genetic merit of their animals and keep cull decisions without that pedigree, without that birth information. Further, I think from a lot of breed standpoints, you get a lot more breed integrity, you get your own stud integrity, and it just has that overall reliability. It allows us to say our animal is what it is and it's going to perform how we describe it to perform, and just have that overall integrity behind it. So from a risk mitigation standpoint, a lot of people are using the technology. Also from an inbreeding management standpoint, a lot of people then you understand exactly where you stand, so that's why a lot of commercial people want to use it now too, at least at that sire verification level, so then they can then select bulls accordingly and mate accordingly. Another one, management of genetic conditions, that's pretty self-explanatory. You can see where you stand, and then you don't need to worry about, well, you have the option. For instance, there's been breeds in the recent years that have come up with new genetic conditions, and therefore they can understand how they market their bulls, whether it goes into a crossbreed operation as a carrier or as they can stay in the stud system. Similar with cows, they can decide to keep cull. There's that management advantages for multi-sire joining, tightening up. You can AI put a bull straight out, then we can sire verify. You can really tighten it up, and a lot of people like that standpoint. You can syndicate mate, and then yeah, it just allows a lot of reduction in on-farm costs associated with collecting information, or you see it in the sheep industry. Instead of going out there and tagging every lamb at birth, now they'll just be able to collect genotypes at marking or weaning, and then we'll be able to fully parent allocate for them. There is also a lot happening in that marketing advantages. So more stable EBVs, I guess, is a very, very big one. That's we have peak periods around sale time, so then animals can be accurately described, and then also we're looking at trying to get a bit more market access there. We've just put Laura Garland in the supply chain role, so she's trying to work with a lot of feedlots, processors, agents to ensure everyone along the supply chain understands genomics and then how to extract value out of it. And then also what can come from that. So in terms of that marketing perspective, marketing lines of cattle, if you've got something on Auctions Plus or a similar platform, and actually displaying data and capturing some value on that. So the role of breeding animals, we all know this, you want an animal to breed better than it is. We all say that, we want that cow, we know that cow's great, but the best cows are those that breed better than they are, or size that breed better than they are. So basically, the role of breeding values is looking at that whole, without them, how do we identify animals with superior genes? So as I've mentioned, when we're looking at an animal, only a component of what we're seeing in that differences between them is that phenotypic difference, and then there is some due to genetics, and it's what we can't see, so it's describing what we can't see when we look directly at an animal. Some traits are also sex limited, they're hard to measure, and some can't be measured prior to selection for use. So it's also difficult, as you know, to compare animals between different herds and environments, and so that's where breeding values come in to enable us to identify the genetics of an animal, and genomically enhanced EBVs allow us to do this. So we're just going to touch a little bit on understanding genomically enhanced EBVs. So prior to turning on single step, or the breeds that don't currently have single step, it's all coming from your pedigree and your phenotypic data that's getting entered. It's going into that genetic evaluation, the calculations are happening, and the EBVs are getting spit out, and then we're allowed to make selection and genetic improvement from that. But with the use of single step, and that genomics, so that DNA profile filtering into the system, it's a new generation of genetic evaluation. So it's allowing us to go faster and therefore make genetic improvement much quicker. So genomic breeding values rely on the existence of a reference population. So a reference population, also known as a training population, is comprised of animals with genotypes that also have all that comprehensive performance data behind them as well. So they've got a birth weight, they've got a 2, 4, 600 day weight, they have that scan data, and so they're really, really robustly described animals, and that's building that reference population that then we're going into reference back to. From that training population, SNP effects are calculated, which I won't go too in depth from, but by having a comprehensive reference population, it's allowing us to use that DNA and DNA-only products even to then link them to animals, and we'll talk a little bit more about that. The accuracy of genomic breeding values, as I've mentioned, is influenced by the size of this genomic reference population. So as you guys are probably aware, you had to get to a certain count to be able to turn on single step, and there's still breeds working towards that. And it does take a while, and it's going to be different on traits as well. So the heritability of traits is going to impact how many actual records and genotypes you need for that certain trait within the system to allow you to turn it on for genomically enhanced EBV. That comes down to also the relatedness of animals. So within a reference, I think it's a good to look at. I come from a Red Angus background. I put my animals into the taste analysis. I'm actually excluded because I'm not actually linked. So that's the relatedness of the reference population, and so it's now going to have to be creating some linkage there as well. You see that also a lot we have products that are available or genetic evaluations that are available overseas, but you could be distantly related to that reference population, so the accuracy of your figures that you're getting back is not going to be as accurate. And similarly, in those multi-breed evaluations, you could come up with, if your breed's not included, some things happening there too. So as we've mentioned, prior to genomics, or anyone that doesn't have single step turned on, we're looking at it as everything. You're getting 50% from your mum, 50% from your dad, or the dam and the sire, and then that's just how simple inheritance is going to work. But it now allows us. So by having genomics now, you're going to get that more precise pedigree relationship. So knowing that you might have got 46% of your DNA from your dam and 54 from the sire, and then where that goes further up into that. It also allows us to see the additional relatives or anyone that those animals are closely linked to. They might not have any pedigree link there, but they're carrying very similar DNA markers throughout their genotype, so therefore we can see and accurately describe them and how they're going to perform into the future, because we've got that comprehensive reference population behind it that's really well described. We're seeing variations, we can look at that and see how animals within that have performed, and therefore predict how others are going to perform into the future. This is a good snapshot. I know it's an Angus-based one, but I think we don't have anything available like this for Speckle Park, and Paratroop is a pretty well-known sire that was used commercially and stud very comprehensively, and it just shows that overall relationship. So if we're looking at the graph on your left there, that's showing the sire-offspring genomic relationship. So all those direct sons or daughters from him, we can see that variation in how closely related they are to him. And then similarly, once we break it down further, we can see how closely they are related. So anyone that's used and has a paratrooper son, how distantly or closely related they are. So calculation of breeding values, this is kind of just a summary. So the prediction of a breeding value is based on understanding the relationship between animals, and that's within pedigree. It's also then further to that overall reference population, and as I said, that really robust now link that we can see between animals that are not within that pedigree. Using the performance measurements that are available on an animal and other animals to which it is related to estimate the genetic merit. So I just wanted to really highlight that next part too. Genomics replaces the need for pedigree information, but not performance measurements. So in saying that, basically the pedigree information allows people to come in and use DNA-only products and not know the pedigree behind their animals. But it's in terms of your standpoint in a breed, you really do need to know that you really still need to take some performance measurements just to keep contributing to that reference population, build it, and just make it really robust moving forward. So looking to the future, I just wanted to touch on a few things that are happening at the moment. I guess the really beneficial thing about Neogen is that it is very progressive, and especially in that commercial space. So we are currently, MLA is currently working on the multi-breed genetic evaluation, and that will be available hopefully. They're working towards it over the next 2 years, but it won't be available any earlier than that, and that would hopefully be available to anyone with single steps, so Speckle Park, Brangus, Angus, Herefords, Charolais, any breeds that have single step turned on. We are also, as some of you might have heard, there is a commercial offering that's coming to the marketplace for Hereford cattle, and so again, it is through BreedPlan. It uses BreedPlan reference population built by the Hereford stud breeders, and it's allowing commercial Hereford breeders to get access to DNA-only testing to allow some trait analysis and genetic merit analysis. I have been getting some questions because you guys are a single step. Are you guys in the pipeline to getting this in the future? At the moment, there hasn't been any discussion. It's kind of like Herefords first and then into Bos Indicus breeds, and then they'll look further into that depending on timelines and depending on timelines with the multi-breed genetic evaluation. But that's just showing you that there is a lot of developments in there that will really help your clients that you might be selling into. And then I just wanted to finish up on this slide, and it's just how do we extract value out of genomics into the future, and you're probably across a lot of this, but I just think it's a nice reminder. So why we don't have value-based marketing at the moment, I think this is a nice tool to be using and to start making some really robust breeding decisions. You might have a breeding objective that is really that carcass quality, eating quality, but tenderness side of things, and so you guys can really set yourselves up now and start making decisions into the future where we can see that cumulative effect, and then when these do come into play and there's some models around it, you might be able to capitalise on that sooner than a lot of other people in the marketplace and other breeds in the marketplace. I think it's also, I just want to touch on, as I have mentioned, that commercial herds perspective. Like I think what I primarily do out in my day-to-day is a lot of work with commercial producers, and that's benchmarking females. Some are just doing simple sire verification, but others want that descriptor, that data to say, okay, my animals are sitting at this level, I need to take them to here, this because it's my breeding objective, make some accurate bull buying decisions based on that and really amplify where they're going. Also for that, we're seeing it in both the drought strategy, so then they know, okay, this is my cows, I know exactly where I'm standing, it's going to get tough, or it's got tough now, I'm going to cut out the bottom 10% and they can know genetically where they're sitting. Also in a drought, we know that the environmental factors that comes into play there, they could be genetically elite, but they're not having the opportunity to express that genes because it's tough, they're not getting the overall feed that they might be requiring. So it allows you to analyse that component as well. And then we're also seeing it on the other end in the rapid herd recovery, so identifying superior animals in the buy and buying back animals too. They can buy in runs of hundreds of cattle and go through them and then really tighten up your herd really quickly to where you want to stand, make them really close genetically or closer to your breeding objective, cull out the rest, so you're not just feeding something on or keeping something and hoping it's going to perform. We're coupling with ag tech, which you guys are probably very familiar with. So in a commercial setting, they're doing, as I mentioned, a genomic test, and they might be AIing their most elite animals. In your setting, in a stud world, they're using it coupled with IVF or ET to really create that selection intensity we were talking about earlier and really amp up production. From a sustainability standpoint, you guys probably are already starting to select for a lot of traits that are going to improve the profitability, which increases sustainability and efficiency on in your enterprise. So that fertility component, that growth component, turning animals off quicker, and yeah, just appealing to that sustainability side of things. But then on top of that, we're seeing a lot of feedlot use now through products that are allowing feedlots to know how to feed an animal and when optimum days on feed, short fed, long fed programs, how it should basically perform and therefore market accordingly. And then from that, as I mentioned, Laura Garland stepped into the role of supply chain to really look at that market access and marketing opportunity. So supply chain recognition of genomics and genomically tested animals and how we can extract value for everyone. I think there is a lot of scope there in terms of grouping cattle accordingly, marketing them accordingly, and then everyone understanding how they can use that data moving forward. But yeah, if anyone's got any questions, hit me, and I hope you got something out of that.
Everyone put your hand, thank you.